Ever wondered how Datadog decides which traces to keep and which one to drop? By default, the Datadog agent targets just 10 complete traces per second per agent. That's your baseline head-based sampling in action. But here's where it gets interesting. You can tune it, override it, and even add rescue nets for error cases. Today, I'll take you on a layered walkthrough, from head-based sampling to custom rules, error and rare trace catches, and retention filters. This is only part one, but it will cover some of the main concepts to get you started. All right, let's start with the foundation. The default behavior, head-based sampling. The sampling decision is taken from the entry-level service before anything happened. Think of it like a faucet. No matter how much water, that is traces, your application is generating, the Datadog agent keeps the flow steady, at around 10 complete traces per second per agent. So how does it work? The Datadog agent continuously calculates sampling rates to approximate 10 complete traces per second per agent based on real-time traffic levels. For low-traffic services, this may mean sampling 100% of traces. For very busy services, it throttles them down to maintain that 10 trace as target. The decision happens at the root span, the very first part of a trace, and is then propagated downstream across all services via the trace context. That means either the entire trace is kept or dropped. It's never partial. This head-based approach is efficient. You sample right at the entry point, and your decisions propagate consistently across every downstream service. Why does it matter? It scales. They don't let one service's traffic flood your ingestion pipeline. You maintain visibility into representative traces without being overwhelmed by volume. And it's cost-effective. You get just enough data to surface performance issues without excess. If you want to tweak this default behavior, say, capture more traces during a specific time window, you can do so using the agent level setting. max_traces per second or environment variable dd_APM target TPS. Adjusting this influences the calculated sampling percentages for all services under that agent. A pro tip, tweaking this globally impacts all services sending to that agent, so only adjust when you're sure of the impact. And one quick note before moving on. The traces coming with this default head-based sampling will be flagged with ingestion_reason auto. Why keep it simple? Because most of the time, the default head-based sampling is sufficient. It's simple and cost-efficient. You get end-to-end trace visibility without manual setup. And it sets a baseline you can always build on with custom rules later. So if you don't know how to adjust your ingestion sampling, stick with the default. So that's the default baseline. A smart self-tuning flow targeting 10 traces a sec per agent, with a clear root span decision logic that ensures whole trace consistency. It gives you visibility and control without an avalanche of data. When you're ready for more precision, that's when we'll layer on rules. Okay, so the faucet is flowing at that default 10 traces per second. But now imagine you have certain endpoints that must get VIP treatment. Maybe it's your checkout process or a special API call. That's where sampling rules step in. They let you override the default flow, service by service, resource by resource, while still benefiting from head-based sampling and complete traces. So what are sampling rules and why use them? By default, the Datadog agent calculates and distributes sampling rates to hit that 10 trace sec target per agent. But with sampling rules, you can override that for any root-level trace initiated by your services or endpoints. This means you can send more or fewer traces from critical parts of your system based on your visibility needs. How sampling rules work. A rule looks like JSON. Here's a quick example. The tracer library examines the first span of each trace, the root span, checks it against your sampling rules, and applies the first matching rule to decide the sample rate. If none match, it falls back to the agent's default behavior. First rule says, for my service, get/checkout calls, sample 100%. Then for everything else in my service, drop it back to 20%. This rule logic is evaluated in order, so placement matters, first match wins. You can configure sampling rules using the environment variable, dd_trace_sampling_rules, which takes a JSON array of your rules. If no rules match, the agent keeps its default behavior, but as soon as you add rules, you then enforce the rule configuration. In that case, the ingestion_reason will be set as rule. Of course, if the decision is already taken by an upstream service, this rule will not be taken into consideration. Why it matters for engineers? Precision. You get trace visibility into what truly matters. Purchase flows, auth checks, APIs without noise. Control. You're not at the mercy of the default global agent config. You can push more data through when it matters or dial down when it doesn't. Autonomy. You can apply this control at the tracer level, and no app restart needed if remote config is set up. Now let's go for a quick recap. By default, each agent targets 10 traces per second. You can then override it with sampling rules. Those are set at the root service and can be defined at service and resource level. This matters because it gives you control over what you see. Think of it like valves, one for checkout, one for API, one for auth. You decide which ones open wider. Let's talk about your safety nets, because even when your faucet drops something, you don't want to lose critical data. That's where error sampling and rare sampling come in. So let's start with the error sampling. How does it work? Even if the head-based sampling drops a trace, the error sampler ensures that traces containing error spans still get through. It can rescue up to 10 error traces per second per agent by default. So why does it matter? Errors are often where the action and the insight is. You don't want failures to vanish into the ether. Customization and configuration. Optionally adjust the number of error traces per second using dd_APM_error_TPS. Finally, the traces kept with such sampling system will be flagged with ingestion_reason error. One key difference from head-based sampling is timing. Errors can appear later on in execution, sometimes within subservices, or only at the root service. That means the error sampler may not always capture the full trace. So when reviewing an error trace, if it looks incomplete, always check the ingestion_reason tag to understand why. Now let's move to rare sampling. So how does it work? Rare sampling targets low frequency, potentially important traces using combinations like environment, service, resource, error type, or HTTP status. It sends up to 5 rare traces per second per agent by default. In addition, with such sampling system, the traces will have ingestion_reason rare. So why does it matter? Critical endpoints with unusual traffic patterns, think internal admin calls or rare feature paths, might otherwise be invisible. Rare sampling keeps them visible. How do you set it up? Depending on the version, it's not enabled by default in the agent. So check the doc and explicitly enable it via datadog.yaml or environment variable, dd_apm_enable_rare_sampler if need be. Why did Datadog put those guardrails in place? First, even if head-based sampling misses something, these mechanisms help catch and forward traces bearing critical signals. In addition, it keeps visibility for outliers. Rare sampling ensures you're not blind to odd but meaningful behavior. Finally, it keeps costs manageable. These samplers operate within small fixed quotas. They're effective and economical. In short, error sampling gives you a safety net for failures. Rare sampling gives you a window into unusual behavior, and both operate silently alongside your regular head-based flow. Now that we've set and safeguarded our trace sampling, let's talk retention beyond the first 15 minutes of raw data. That's where retention filters come into play. They let you index the right spans and maintain long-term visibility without blowing your budget. What are retention filters and why are they the game changers? The intelligent retention filter is always on. It works like a smart curator, automatically keeping a balanced mix of traces so you don't need endless manual rules. On top of that, you can create custom retention filters based on any span tag or attribute, ensuring you keep the data most relevant to your business. Both intelligent and custom filters store data for 15 days, the standard trace retention window in Datadog. Let's break down intelligent retention and how it decides what to keep. This filter actually applies 2 sampling strategies simultaneously, diversity sampling and 1% sampling. With the diversity sampling every 15 minutes, it ensures at least 1 trace is retained for each combination of environment, service, operation, and resource. Plus, it captures high latency spans at P75, P90, P95, and maintains error diversity across status codes. With the flat 1% sampling, it uniformly retains 1% of traces, based on trace_ID, applying the decision across the entire trace. And here's the kicker. Spans indexed by intelligent retention don't count against your bill. That's free visibility. Want full visibility into those high-stakes traces? Use custom filters. Define queries like all checkout spans above 2 seconds in production, credit card transactions above $100. One important thing to note is that when an index span is clicked in Trace Explorer, you get the entire trace context, even if only a span is actually indexed and searchable. If you are not sure how much to keep, go progressively and use datadog.estimated_usage.apm.indexed_spans to monitor how many spans you're indexing by environment or service. Let's review the best practices for retention filters. Sequence carefully. Filters run in order. The first matching filter executes. Put the most specific ones, like 100% retention for checkout, at the top. Make them meaningful. Use clear names and assign owners to avoid forgotten or overlapping rules. Fallback with intention. Consider adding a catch-all filter at the end, for example, unmatched spans that are incomplete, to capture edge cases. In short, intelligent retention gives you curated, cost-free visibility into diverse and high-value traces. Custom filters let you retain exactly what your team needs for deeper debugging or compliance. It's strategic retention that builds on your sampling foundation, and it doesn't break the bank. The sampling story in Datadog doesn't end here. This is just part 1, but it covers the core concepts you need to know. It may seem complex, but remember, the default setup is often more than enough. No extra configuration needed. If you do need more, layer on custom rules for key services and resources. And always monitor costs to stay on budget. For more Datadog best practices and tips, don't forget to subscribe. And as always, happy monitoring.